So here we have an exploded view of what we call a camera-driven Vejo with a new board that we ported the firmware onto. This board, we have actually not only ported the existing firmware onto it, but we also created new firmware for the camera and the motor. It has all the features of the existing firmware, including hibernation and things like that, but it also has Wi-Fi support for things like in-place firmware updates. So there's extra magic in there. The board, which has a hat on it so we can connect things, is right under here. And it is actually faster than the Octavo. It has a quad-core 1.2 gigahertz running on it. It's got 8 gigabytes of eMMC, 12 gigabytes of memory. It runs Linux, which enables us to add voice, which is what Aaron's working on, and to add rich displays, because Linux is really very powerful. And it really allows us to do one board for everything, which we'll get into later. The camera, which is right here, is a 20 megapixel barcode camera that is designed for industrial applications. It can read up to like 200 barcodes per second. It's super powerful. It's all connected in here. The motor is a 7,500 RPM brushless motor. It's got a built-in controller board, and there's no need for an external motor controller board here at all. It measures impedance on the motor to calculate viscosity. Aaron, so you might want to, what do you want to weigh in on that a little bit?
With a homogenized liquid, the impedance on the motor can be linearly correlated to the viscosity. With this motor, as opposed to the one that is in our current bottle, it has a direct output that allows us to read that instead of just a power source, as well as the fact that it allows us to control the direction and be able to jig back and forth with different various glitches.
Yeah, what I think is important is that Aaron's capstone project USC was testing motors, and really with the kind of like resistance we're getting in the bottle from the bearings, you know, a higher RPM motor might work better or get us in the right zone, right, for what we were trying to achieve. So, but there's no need for a motor control board or a power management board in this setup. All of that can be put onto this single board, so it can be a one board solution. There is no level sensor in this, capacitive level sensor, but it will be done with a refractive measuring LED to make things simpler. As you can see here, you have the mobile app is already connected to this via Bluetooth. And Aaron, if you point over there, it's also connected via Wi-Fi to showing the actual firmware as it's operating. So you can even debug it, you could see the status of what's going on. So why don't we, Sean, scan a pod and make this thing work?
Yeah, before I do that, since we don't have it in a bottle, this particular little board here is actually the lid close button as well as the LED. And so essentially what happens is when clicking this button, it'll trigger lid close, which will then cause the read to happen, which will turn on the camera. And the minute we actually read it, it'll actually start the blending cycle. So at this point, if I hit this button here, you'll see the LED turn on. Here basically is a barcode, so I'll just putting, and now you'll see
the motor
turning on. And then also on the mobile app, you see it blending that particular one. And right now, that particular blend is happening. So essentially, it'll blend for 30 seconds. And on here, on the mobile app, you can actually see, it tells you the RPMs, at what the RPM is running at the moment, as well as, you know, anything that happens. So if the motor blocks or anything like that will display. So right now the pod has been blended, and if we go back to the application, if we look at this at 3:57 p.m., 3:57, we blended the red Taisu. And now basically at this point the light is flashing and it's ready to blend the next pod. So if we were to take another pod, you know, but at the same time, before we do that, since we did say that we are connected over Wi-Fi, what we do have the ability is to go in and, let me just look at this. And what it's doing is right now, it's showing me, because this is Wi-Fi connected, it's showing me, for instance, the load on this, the CPU load, the temperature inside, how much memory I'm using, the network connectivity in terms of any Wi-Fi, how much this. So this is a real-time update of the stats of this thing being pulled over the browser and facilitating us to be able to look at a bottle over Wi-Fi, even though it's totally disconnected.
So dude, one of the problems that we had in the past was worrying about how we could chunk or send firmware updates over Bluetooth Lite and BLE. So here we have an in-place Wi-Fi connection where we could actually do large firmware updates. Entire images can actually be sent over right onto using this.
Yes, so basically what it does is, even though, so for instance, if someone does have a problem, we have the ability to come in over Wi-Fi and debug the bottle. We are able the ability to actually do the firmware updates and basically even take it to say, if we want to extend it and say, hey, you know what, right now it's just going over Bluetooth, but let's make this an IoT device. We have the ability to go in and from the bottle go directly IoT. So those are some of the advantages of having the Bluetooth. But what you're seeing here really is if I were to just go in here, if you look, the board is really 40 millimeters by 40 millimeters under here, and the only reason the hat is on is to facilitate us to connect everything up easily and dismantle it. It doesn't have to be at that size. So anyway, let me just